So, with the completion of unit number 3, we have found out, we have studied about center of gravity, mass moment of inertia, polar moment of inertia, etc., all this. And the next unit, the topic is, that is unit number 4, is dynamics of particles. So, the two different divisions, statics and dynamics in mechanics. So, that part is over, statics part is over, now it's dynamics. Basically, dynamics means, you can say it's movement. It is not moment, it is movement. A particle, a force applied to a particle, or analysis of that force, when it is moving, that you take it as dynamics in general. But dynamics is actually divided into two subdivisions. One is called kinematics, okay, and other one is called kinetics, kinetic energy. This is all your basic physics in plus 2 what you studied. So this kinematics is, okay, so kinematics deals with when a force is applied to the body, when the magnitude of the force is not considered, right, it is kinematics. That is without considering the force applied, without consideration of force. That means you are finding a solution or solving a problem without considering the force. The force is not taken into account. That part is called kinematics. And kinetic means, very simple, what is kinetic energy? Basically half mv square. Is it not? So it is consideration of force. When force is taken into consideration, considering force it's called kinetics. And this kinematics and kinetics is the two different areas. Now under this we have something called rectilinear motion. Rectilinear motion. Another one is called curvilinear motion. All this you have done in your plus 2, but still just a overall view in this. What is rectilinear motion? And a force is applied to a body and the analysis is made just for any force applied in a straight line or a body moving in a straight line. We are just calculating the values of its displacement, velocity and acceleration when a body is moving in a straight line motion. It is straight line. IGHT, straight line motion. A body is moving in a straight line for which we are finding out displacement, velocity and acceleration is called your rectilinear motion. And curvilinear, again very simple, about the curved path. Finding out your displacement, basically displacement d, okay, velocity v and your acceleration. These three are very, very important characteristics of your rectilinear or curvilinear motions. So to finding out displacement, velocity and acceleration, when the body is subjected to a straight line motion, that's called rectilinear motion, and when it is subjected to a curved path motion, body moving in a curved path, that's called curvilinear motion. So what is displacement? Basically rate of change of displacement and velocity and accelerations. So all these your rectilinear curvilinear motions in this chapter, it has been tabulated in different view, which means depending on whether the body is moving either up or down, or whether the body is moving either right hand side or left hand side, whatever it is, depending on its movement, it is dynamics, dynamic movement of the body, the formula is defined. For example, I'll just write, this is the characteristics I can write, and when the body is moving up and it is down, that's all just tabulated formulas in the book. So V is equal to U plus AT is a formula. This is your basic physics. What is V here? Velocity. U is initial velocity. V I can take final velocity. A is acceleration. T is time. Right? So like this, there are set of formulas. This is for velocity, for displacement. Okay, displacement, right? S is equal to ut plus half at square. This here again physics. I need not explain much in this concept because you already done in physics plus 2. So this, the way of finding your velocity, displacement and acceleration with different formulas with the base of your rectilinear and curvilinear motions. And mostly the curvilinear motion is much considered in your chapter. Along with, without studying rectilinear motion, if you jump into curvilinear motion, it will be, you cannot fulfill the total idea. You don't get the full idea. So we will see what is rectilinear motion based on different formulas and 1 or 2 problems in that. Then we will switch over to curvilinear motions. So we have seen the basics of dynamics of particles. So what I just recall what we have gone through. So dynamics is divided into 2 main subdivisions. It's kinematics and kinetics. So kinematics is basically based on the analysis of your velocity, acceleration and displacement, but without considering the force which is actually acting on that, any body. Okay. Whereas kinetics is you are going to calculate the force and its effect also. That is the difference between kinematics and kinetics. And basically, for any body, the velocity, displacement, I can say displacement, velocity and acceleration. These 3 important characteristics, okay, are very, can say these are basic characteristics required to be studied and to be analyzed. Here are a set of formulas, okay, which is usually for a rectilinear motion, and these relationship will be useful for calculating any value or to find out either velocity or acceleration or displacement when a body is in motion. Now this has been subdivided into 3 categories. One is horizontal motion, second one is vertical motion, but when you say horizontal it may be either forward or backward, right? But when vertical, there are 2 types. One is a downward motion or it is upward motion. What is the meaning of that? Downward motion means I am just holding a chalk piece, I just leave it down, it's downward motion. So upward means you are going to throw a particle, right? So there are 2 types of different motions. For this, different set of formulas are given. The purpose of these formulas is to know the relationship between or to find out any value, either the velocity or displacement or acceleration using these formulas. So the horizontal motion, the velocity, I can say it's the final velocity, is given as is equal to initial velocity plus the acceleration applied to the body into the time in seconds. Like that, there are number of formulas for your velocity. This is displacement S, and again velocity in terms of different possibilities of the acceleration as well as the displacement, as well as the nth second. That means in the number of seconds of, say for example, when you compare 2 bodies, one body is moving in one acceleration in some particular time. The other body starts with either a late or let's say forward. That type of difference of your acceleration, a moving particle, can be calculated with this formula, that is S nth. This is displacement at nth value. That means n you can shoot for anything. N may be 4 seconds, 5 seconds, 10 seconds, or 100, or whatever it is. So it is based on that particular value of n. Then when you come to vertical downward motion, it is u plus the difference between this horizontal and vertical is what? Here the acceleration A is the acceleration applied, A is meter per second square, as well as this G is also meter per second square only, but this G is acceleration due to gravity. Okay, which should be due to gravity. Naturally it is available, it is possible, and we'll have to calculate. And this acceleration A, it is due to the application of the force. The small a, hope I told in the previous chapter, the small a is not possible without applying a force. A is to be calculated only when force is applied to a body. And this G is an acceleration due to gravity, meter per second square again. That value is 9.81. That's your basic physics. That is possible because when a body is moving either an upward motion or just falling down due to the attraction of the earth, that value is that, gravitational force value. That's it, U plus GT. So you can just by the names of vertical downward motion or upward motion, this symbol, the parameter changes, this G, because you can understand if it is downward motion, either it is up or down only, you need to write this G. And very simple difference is it's minus here. Why it is minus? Because of upward motion. In the sense, this I am just holding a chalk piece, I am just leaving it. This is called free, the body is falling freely. So acceleration due to gravity is the one because of gravitational pull of the earth. So this is taken as positive because any body, if you leave it freely, it will fall down because of acceleration pull due to the earth. So this is taken as a positive one. This G value is taken as positive 9.81, I can say, meter per second square. But when it is vertical upward motion, in the sense when I throw this body, particularly this chalk piece, it's been thrown up. So what the actual condition is? The body will have to fall down, but you are just throwing up. When applying force, throwing up. So that acceleration due to gravity, because it's going opposite to the natural fall, is it not? Naturally, if you leave a body, it will fall down. So when this body is going opposite to the natural fall, you will take it as minus value. It is minus G. That's it. So all this set of equations, it's plus or minus depending on your vertical upward or downward and horizontal things. The basic requirement is to find out a velocity or acceleration or displacement. These relations should be known. So with this set of equations, you can calculate any number of formulas. So this is as such given in your textbook or your reference book. So you will have to remember when you say a velocity, what are all the possible formulas or equations available to calculate a velocity. Just maximum one or two. This is one equation for velocity again, for horizontal motion. One more here, velocity. And like comparing to the way motion of the body, it's up or down or horizontal, you can choose the equation, you have to remember it and solve the question. That will be very easier to find out. Then after this, one more step, something called relative motion. The next topic is relative motion. Basically, the name it's relative. The motion of a particle or a body related to another. Say it may be a particle or a body or to a surface or a space, whatever it is. Now a very simple example is, I'll just sketch say fine. This is just a table. Okay, this is in the horizontal floor, horizontal surface, right? I'm just going to place this chalk piece or say a duster, a small body on this table. Okay, this is a body. Now my intention is to, my aim is to move this body from say suppose position A to suppose position B to a distance, some distance it is, some distance D or it is given a symbol S, some distance I want to move it. What should I do actually? I can just hold this body alone, take it up alone and displace it or replace it in other, at point B, one possibility. Other one, I can move this complete table, is it not? I'll just move this table totally here. So this table is also moving from say point 1 to destination 2, and this body will also be moved here. So the relation in the relative motion, say suppose this is body A and this is body B and just this is point C. The relative motion of this body A with respect to this body B can be calculated using any set of formulas what we have before. Or the relative motion of the table B with respect to this body A can be also calculated with this set of formulas. The purpose, the useful of this is, for example, if I have two vehicles, say two car A and car B. Okay, this car A may start at say suppose 5th minute, okay, and car B will start by 10th minute, whatever the time delays. So the relative, and it is moving in a horizontal road or a line. The relative motion of these two bodies, either car A or car B, can be calculated using this kind of relationships. Okay, so this is useful in easily calculating. Though the formulas are this set of formulas, so the relative to one body to the other body, that value can be calculated. Again, velocity, acceleration, and displacement. That we will see in solving one or two problems. But the total aim is to see that this set of formulas has to be remembered, to be understood. What is V here? Final velocity. U is initial velocity. A is acceleration. T is time in seconds. Like that every parameter here. A is the acceleration. N means nth seconds. What is 4 second, 10 second, 20 second, whatever it is. I just want to calculate the displacement at 4th second. Displacement of a body at 20th second. So this formula is useful in that way. Initial velocity, and these are even the h. H shows the height of a body which is falling downwards at some different seconds, n second, where you calculate again the value of acceleration due to gravity and initial velocity, all this. So in basically what is the unit here? Your u is initial velocity, because I already many times told that engineering mechanics, any problem you need to solve it, you have to solve it with proper unit. When you don't write an unit for any quantity given here, this becomes senseless. The answer becomes senseless. So it's very important to write the unit, whatever may be the problem solved. If you write the perfect answer exactly, you calculate the answer, but still if your unit is wrong, you will not get any, not even a single mark. You will get 0. So it's very, very important. Velocity again, meter per second. Final, the same thing. It's final velocity, meter per second. What is displacement? In terms of meters. Acceleration A or G, whatever it is, meter per second square. And anything else you require here? Also this height h. Okay, again meters. So these are common units what you will study in physics. With this you can solve few problems on that. Okay. So this relative motion again, with this set of formulas, when two bodies are in motion, compared to related to one body, what is the movement of other body? The motion of other body can be calculated with this topic, relative motion. That we will see in the problems, right? Under relative velocity, this is a small line diagram. Say this is considered body A, this is body B, which is traveling in a horizontal direction. Okay, horizontal direction at with some different of speeds, I can say. So if x1 is the distance from the starting point of the body A, and x2 is the distance of body B, here S is a symbol of displacement. S is displacement. Okay. Here you can note here, at body A point is here and body B point is here. So with the difference between A and B, the displacement is given as displacement of body B with respect to or with relative to A, which means x1 is a smaller value, the body A is being displaced at x1 distance, body B with x2 distance, which is a bigger one. How do we just to find out this value? Just simply x2 minus x1, which means I want to know the displacement of body B relative to A. If I want to know displacement of body B alone, what is this? X2. Suppose if I want SB, it is X2. Is it not? Suppose if I want, I have written here, displacement of body B with respect to A, that is SB minus SCA. This is the relative displacement. SB is alone X2, that is this length alone. B is traveled at a distance of X2 and A is traveled at a distance of X1. It can be just calculated like this, X2 minus X1. Now if you want to know the velocity, what do you have to do? So this symbol denotes, kindly remember, this symbol denotes the relative displacement of body B related to A. Suppose if I write A to B, vice versa, same thing it is. So this is the displacement now. If you want velocity, what will you do? once you differentiate displacement once, you will get velocity value. Now d by dx of your displacement, what will you get here? Dx2 by dt, is that not? Minus dx1 by again dt. What will be your velocity? So this dx2 by dt and dx1 by dt I can write in terms of here velocity of 2 or b minus velocity of a, is it not? So it becomes here, this symbol I can write it as v b bar a, displacement velocity of body b with respect to a. So finally we will get this velocity of body b relative to a is equal to velocity of b minus velocity of a. The purpose of studying this is when two bodies in motion with some difference of time or acceleration, you can find out the relation, with the relative motion equations you can find out the value of displacement or acceleration, velocity. This is the purpose here. Okay, let it be as it is. Now here's one problem. Okay, so I'll just write this equation velocity here. Unlike this displacement of body b related to a is sb minus a, velocity of body b with respect to a is velocity b minus velocity a. That's all. See, the bigger one minus the smaller one, that's it. You see the difference. Now one problem I've written here. Car A travels at a speed of 30 meter per second. Okay, and car B travels at a speed of 20 meter per second in the same direction. Both are in the same direction. So it's a horizontal motion. Determine what is the symbol I told. Instead of writing in words, written in the using the symbol. Velocity of body A with respect to B. Two bodies are moving in the same direction, car A and car B. You have to find out the velocity of car A related to car B and velocity of car B relative to car A. This one, two things you have to find out. One more option given, if car B travels in opposite direction of car A. That means if car B is traveling opposite to the direction of car A also, the second option we have to find out velocity of car B with respect to A and velocity of car A with respect to B. Same, right? Now basically you just can write a line diagram. This will say this is car A, this is car B. Car B. What is the value given here? Travels at a speed of 20 meter per second. Right? What is this 20 meter per second? U of A is 20 meter per second. 30 meter per second. Right? And that of B, U or B, whatever it is, the velocity, this is the velocity only, okay, is 20 meter per second. Now we have to find out, determine the velocity. So velocity of, what you want? Initially you want velocity of car A with respect to or related to car B. What is the formula? A with respect to B. You can simply write VA minus VB, that's it. Is it not? And before this, one important note is, for sign convention, for our understanding, in the horizontal motion, the motion towards right hand side, the value of right hand side motion is taken as positive, or the velocity values, whatever it is, and the left hand side values are taken as negative. Okay, so a body may move in towards right hand side or left hand side, whatever it is, because one body, instead of this, the second option says car B will be moving in opposite direction, which means you have to take a negative symbol. It's for just the understanding purpose, right? So now velocity of A with respect to B, VA minus VB. What is A here? 30 minus VB is 20. How much is this? 10 meter per second, right? And what is the other one? We have to find out velocity of B, car B with related to A. Again it is VB minus VA. Now what is VB here? It is 20 meter per second is VB value, and VA is, it's higher, 30. What should you write here is, you get minus 10 meter per second, but you will have to write this 10 meter per second value bracket negative direction or opposite direction. Opposite direction. The value is 10 meter per second. Okay, that is velocity value. Velocity, you cannot say this value is negative. There is no meaning. Which means the 10 meter per second is a value, but moving in the opposite direction. That is the relative purpose of relative equation is to find out this. Right. Now the next topic of this here, if the car B travels in opposite direction of car A, means I just change this sketch. Car A is moving towards right hand side, and car B is moving towards left hand side. That is meaning opposite direction of car A. This car B. Excuse me. What is the value of here? This is 20 meter per second. Again 20 meter per second. Velocity of B. Now what will happen? Again I have to find out velocity of car A with respect to B, as well as velocity of car B with respect to car A. Now just see the change. What will be the change here now? See, velocity of A with respect to B, the formula holds good, same. VA minus VB. What is VA value? 30. What is VB here? VB is 20 meter per second, but sign convention is, if a body is moving towards right hand side, positive velocity, left hand side, negative. Now according to sign convention here, body is moving towards left hand side. We have to write minus of, what is the value here? VB is 20 here. Is it not? So it will become plus, this is plus 50 meter per second. This is the difference now. Velocity of car A related to car B. What is the value? When it is moving in the opposite direction. It was in the same direction, we just, according to the formula, equation, we have to reduce it. Now, since the sign convention is opposite, you take it as negative, the value is this. Now, velocity of car B related to car A. Again the formula is VB minus VA. Here, what is VB value here? VB itself is 20 meter per second, but moving in negative direction. It is actually minus of, say I can say you should take minus 20. Is it not? Minus 20, and minus what is VA here? VA is 30. 30 is as such. We will get minus 50 meter per second. That is the value. Now, just see the difference between this one. When both the body is moving in the horizontal direction, same direction as is given here, the velocity, relative velocity of A to B will be 10 meter per second, and B to A was minus 10 meter per second. That is 10 meter only in the opposite direction. Now here it is, again we have to write, actually according to the symbol you should not leave the value minus like this. We have to write it is equal to 50 meter per second in opposite direction. That will be the right way of writing the answer, correct way. So this is the difference. The purpose of relative velocity is to find out when two bodies are in motion, what is the relative velocity within one body to other body.